Hello from ChemHelp ASAP. We're now going to talk about communicating organic structure. So we have on the screen a table. We have 3 columns and 2 rows. Molecular formula is the first column, and this is the most simple way to communicate structural information. I'll be candid, there's very little structural information here, but it is at least a representation of how many of each type of atom you have in a molecule. There is a rule for giving a molecular formula. The first atom type that you list is carbon. So you list the number of carbons, followed by the number of hydrogens, and then all the other atoms follow, and they are listed in alphabetical order, ABC order. So that's how we give molecular formula. It's great for communicating how many of each type of atom you have. It's not that great for giving structural information. So let's move to the next column, condensed structural formula. Now, methane is such a trivial molecule, there's not much structural information to convey. But in condensed molecular structural formulas, it tends to list the molecule second row element by second row element. Now, methane only has 1 carbon, so there's not a whole lot to show here, but we'll see that in the next example. Again, methane's pretty easy, so we'll just move on to the next column. That is the Lewis dot structure. In the Lewis structure, we actually try to explicitly show how atoms are connected. So the structural formula tells us that we have a carbon attached to, and there are 4 hydrogens around it. This is the Lewis representation, and it gives a much clearer structural representation. It is, however, still a flat representation. It's 2-dimensional. We know that these molecules are 3-dimensional. Lewis dot structures make no effort to show 3-dimensional character. From other videos, we know if we wanted to take this another level, we could show that this carbon, it's sp3 hybridized, it's tetrahedral, and so we could give this more detailed type of picture. But that is not a Lewis structure. Lewis structures are flat, and that's where that level of communication stops. So let's go to the next row, ethane. Well, maybe this will be a little bit more informative. Ethane has a molecular formula of C2H6 that gives you no information about how these atoms are connected. When you go to the condensed structural formula, this is how you would write ethane. It's really 2 carbons next to each other, and they have a bunch of hydrogens. So you can think of this as there's a carbon, and that's its molecular formula for that carbon of the molecule, and then there's another molecular formula for the next carbon. The carbon and its other atoms listed often as, on the left, carbons, hydrogens, and other atoms. So how do we draw this as a Lewis dot structure? Well, you tend to write this out 1 atom at a time. So we're going to have a carbon. That carbon, it's attached to 3 hydrogens. And then we're going to have another carbon. And these 2 carbons are going to be attached. That gives us 4 bonds to that first carbon. And the second carbon also brings along 3 hydrogens, so we put those 3 hydrogens in. And that gives us our Lewis representation for ethane. Again, there's no 3-dimensional structure to this, but this is a flat representation. We know exactly how each atom is bonded to another. So these are 2 really simple molecules, methane and ethane. We've shown them 3 ways: as a molecular formula, as a condensed structural formula, and then as a more pictorial Lewis dot structure. And these convey different levels of information that are useful for indicating how your structure is assembled.